Hi all, welcome to the session on direction. The weightage of this topic is one question, and there are three types of problems which are asked. We will discuss all of them. Now, before we start entering the direction questions, we'll talk about the basic directions. This is north, this is south, this is west, and this is east. Similarly, there are four more. This is northeast, southeast, southwest, and northwest. One more small thing on this is sometimes they mention that someone has turned 90° or 45°. So somebody who's facing north, if it is making a right turn on 90°, so when you are facing north and you take a right turn of 90°, you're basically facing east. Anyways, this type will not be important, rather you will be checked on three types of problems. The first is to find out the direction of facing, like which direction you are facing now. Second, direction with respect to starting point. And third, the distance covered. All three problems are easy. I'll start with this question. Gopal starts from his house towards west. After walking a distance of 30 meters, he turned towards right and walked 20 meters. He then turned left and moving a distance of 10 meters, turned to his left again and walked 40 meters. He now turns to the left and walks 5 meters. Finally, he turns to his left. The question is, in which direction is he walking now? Simple problem. What you can do is you can either use this approach. He started walking towards west. From west, he took a right, and then he took a left. Then he took a left again. Then he took a left again. And then he took a left again. So basically, right now he's facing north. So in this question, this distance doesn't matter. When the question is in which direction is he moving now, this distance will not matter. The only things which matter is this right and left. You can draw it like this. I'll do it again. We started towards west, took a right, then took a left, then took a left, then took a left, and then again took a left. Now he's facing north. Well, this is a conventional approach of solving the problem, where you actually have to draw these arrows to find out the direction. Another approach of solving this problem is, step 1, ignore this and only pay attention to the directions. He started from west, then right, left, 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 and left. Now remember, step 2, remember to pair them. Pairing, what do I mean by pairing? Make this is one pair, this is another pair, because this is single, so this will be left. Now what do I do by this pair? Pay attention. If the pair is right and left, or left and right, the direction remains the same. It means whenever the pairing is right or left or right, he will be in the same direction in which he is moving. There will be no change in direction. On the other hand, if the pairing is right and right or left and left, the direction will be opposite of the original direction. The direction will be opposite of original direction. Say for example, if somebody is moving north, he will go south. His facing will be south. Now in this note, let us now try to solve this problem. I request you to please make a note of this 1, 2 and 3 points. So he started from west. The first is right and left. So whenever the direction is right and left, there is no change, and the west will remain west. Now the second pair is left and left. So whenever the pairing is left and left or right and right, the direction will be opposite. It means this west here will now become east. Now from east he took a left, so he was now facing east. From east, if he takes a left, he is facing north. So east plus left is north. Answer is option A. I request you to please write this down thoroughly, because using this we can orally solve the problem. I'll move to the next question. Amit walked 30 meters towards east. Took a right turn and walked 40 meters. Then he took a left turn and walked 30 meters. In which direction is he now from the starting point? So this is a different question where we have to find out his direction with reference to the starting point. So this is a pretty simple question where you don't need to use any formula because there is not much which is given. So I'll take a simple approach. 30 meters east, then a right turn and 40 meters, then a left turn 30 meters. So here, from here Amit started, and right now here is Amit. So I say this direction is southeast. Simple problem. Since the problem is very small, there is no need to actually apply any formula or trick. Moving to the next problem. You go north, turn right, you go north, turn right, then turn right again, and then go left. In which direction are you now? So again, this is a simple question. Facing north, went right again, and then took a left. So if this is the starting point, this is your current point. So I'll say as compared to your starting point, you are on the east. So mind it, this is a different type of question where they're asking in which direction you are now. It means as compared to your starting point where you are. This is not asking where are you facing. So the facing type of questions will be using the method of R and R and L and L, R and L, L and R. If the question is in which direction are you facing as compared to your starting point, then you can easily draw this because there are not much directions which you have to draw. Important question, pay attention. Kunal walks 10 kilometers towards north. From there, he walks 6 kilometers towards south. Then he walks 3 kilometers towards east. How far and in which direction is he with reference to his starting point? So here we have to find out the distance and the direction both. Pay attention. So if this is Kunal, he went 10 kilometers towards north. And from there he walks 6 kilometers towards south. It means he came back. So this is 10, but he came back 6. This is 6. And he walks 3 kilometers towards east. This is 3. So this is where Kunal is currently. The question is how far and in which direction is he with reference to his starting point. So this is the distance you have to find out. I will draw this once again so that it will be more clear. This is Kunal. So he went 10 kilometer towards north and he came back 6 kilometer towards south and he went 3 kilometers towards east. So this is Kunal right now, and the distance between Kunal's starting point and current point is this. You have to find out. Now if this total is 10 and out of this 10 this much is 6, so automatically this is 4. So this part is 4. So here we have a right angle triangle where this is 3, this is 4, and we have to find out this. We'll use the Pythagoras theorem, which is x square equals to 3 square plus 4 square. This will be x equals square root 3 square plus 4 square. This is 9 plus 16. This is square root 25, which is 5. So the distance is 5. The direction, Kunal was standing here and now he is here. So that is, this is northeast. Answer is option B. Rohan walks a distance of 3 kilometers towards north, then turns to his left and walks for 2 kilometers. He again turns left and walks for 3 kilometers. At this point, he turns to his left and walks for 3 kilometers. How many kilometers is he from the starting point? So Rohan walks for north 3 kilometers, then turns left and goes for 2 kilometers, then again turns left and goes 3 kilometers, again turns left and goes for 3 kilometers. Now you have to find out the distance. You can find out the distance. Goes north 3 kilometers, left for 2 kilometers, left for 3 kilometers, left for 3 kilometers. So this is where Rohan is now, and this is the starting point. This total is 3, out of which this is 2, so it means he is 1 kilometer away. Rather than making a diagram, what you can also do is, let us find out answer to all 3 questions, which is the first one, facing, second, distance, and third, direction with respect to starting point. Let us find out all 3 questions. For facing, he started from north. We'll do a pairing LL and L. This will be the pairing LL and L. So from north, if you will take left and left, it will be opposite. And from south, when he will take a left, he is now facing south plus left is east. This is where he is facing now, and from the question we also found out that he is facing the east. Second, to find out the distance, pay attention. Whenever you have to find out the distance d, what you do is you take this first distance and take the third distance. If the two directions between them is LL, subtract the values. If it is RR, subtract the values. What is the meaning of subtraction? We'll just discuss. If it is left and right, add the values. If it is right and left, add the values. Now here we see the two directions are L and L, means subtract this 3 and 3. So 3 minus 3 is 0. This is the value of x. And now take the second and fourth distance and subtract them. Now subtract this from this, so it will be 3 minus 2, which is 1. This is y. And now distance d is equal to x square plus y square square root. Now x is 0 square plus 1 square square root. You can cancel this square and this root. Answer is meter. Now coming to the third question, in which direction is he with respect to its starting point? Here there will be two directions. One is a direction of x, another will be direction of y. Here the value of x is 0. Whenever a value comes to be 0, it means that direction will vanish. And here the value of y is plus 1, it is in positive. So whenever the value is positive, the direction will be opposite. What do I mean by that? And what is the original direction of x? Original direction of x is the direction in which Rohan started moving initially, which is north. The original direction of x is north, and since the value of x is 0, the direction of x is gone, and the direction of y is north plus this first direction, which is left. North plus left. Now north plus left is west, but since the value of y is positive, this west will be opposite, it will be east. So remember, whenever the value of x or y is positive, the direction will be opposite, and if the direction is negative, the direction remains same. I request you to please write this down so that it will be easier for you to refer it. Moving to the next problem. Namita walks 14 meters towards west and then turns to her right and walks 14 meters. Then turns to her left and walks 10 meters. Again, turning to her left, she walks 14 meters. What is the shortest distance in meters between her starting point and the present position? So Namita started in west, walks for 14 meters, then turns right, walks for 14 meter, then turns left, walks for 10 meter, again turns to her left and walks for 14 meter. Now you have to find out the distance. You have to find out, we will find out, the question is not asking, but we will find out the direction of her facing, and we will also find out the direction with respect to the starting point. These are the three questions you will be asked: the distance, the direction she is facing, or the direction with respect to the starting point. Let's start with facing. So for facing we will do a pair. This is right plus left plus left. So she started from west, then right, left and left. So from west, if it is right and left, there is no change. West will remain west. And from west, she took a left. From west, when she takes a left, she will be facing south. So she is right now facing south. Second question. First question, that distance. For finding out distance, what we will do is we'll look at this first and we'll look at this third. The two directions are right and left. So whenever the two directions between the first and the third value, mind it, first and the third value, don't take the second value, take the first and the third value. Whenever the directions are right and left, we will add them. So we will add 10 plus 14, this is 24. This is x, which is positive. So as discussed in the previous question, if it is right and left, add them. Left and right, add them. If it is right and right, subtract them. If it is left and left, subtract them. Now the value of x is positive 24. Now let us subtract the second and fourth distance, which is 14 and 14. So since this is left and left, we will subtract them. 14 minus 14 is 0. This is y. So the distance d is equal to x squared plus y squared. This is 24 square plus 0 square. This squared will be cancelled with this root. Distance is 24. Now coming to in which direction she is with respect to the starting point, the first question here. The original direction of x was west. The original direction, the direction of x will be the direction in which Namita started. This will be always the direction of x. So direction of x is west. And the final value of x is positive value, positive 24. If the value of x is positive, then this west will be changed to east. It will be opposite. Now let us come to y. The original direction of y will be west plus this first turn. Always remember, the original direction of y will be west plus the first turn. The first turn is right. West plus right is north. But pay attention to the value of y. Value of y is 0. Now since the value of y is 0, this direction will vanish. So according to the question, Namita is in the east direction with respect to her starting position. We can actually draw this term . So she goes west 14, then takes a right 14, then takes a left 10, then takes a left 14, so now as compared to her original point is on the east as compared to her present direction. But here they were asking only the distance. Answer is option B. Next problem. Sanjeev walks 10 meters towards south. Turning to the left, he walks 20 meters and then move to its right and moving a distance of 20 meters. He turns to the right and walks 20 meters. Finally, he turns to his right and moves a distance of 10 meters. How far and in which direction is he from the starting point? I'll repeat the question again. Sanjeev walks 10 meters towards south. Turning to the left, he walks 20 meters and then move to his right and moving a distance of 20 meters. He turns to the right and walks 20 meters. Finally, he turns to the right and moves of 10 meters. How far and in which direction is he from the starting point? So we'll find out the distance first. For distance, just look at this first value and this third value. So what we will do is, the middle two values are left and right, so we will add these two. 20 plus 10. 20 plus 10 is 30. So here you get a value plus 30. But now you see there is a fifth value also. So now, and the distance between these two, R and R. So now you subtract these two. This will be 10 minus 30, which is minus 20. So the value of x is minus 20. Now let us find out y. This is 20 and 20. This is R and R. So 20 minus 20, since it is R and R, 20 minus 20 is 0. This is y. Distance d is equal to x squared minus y squared, which is minus 20 square minus 0 square, which is 20. Sorry, this is not minus, this is plus. So distance D is equal to 20 meters. Let us now find out the direction he first goes. This is south. So the value of x is, direction of x will be south and direction of y will be south plus the first turn, which is left. South plus left is east, but since the value of y is 0, this direction will vanish. The value of x is negative, so south will remain south. Answer is 20 meters south. So the distance here is 20. The direction is south. Next question. A school bus driver starts from the school and drives 2 kilometers towards north. Takes a left turn and drives for 5 kilometers. He then takes a left turn and drives for 8 kilometers. Before taking a left turn again and driving for further 5 kilometers, the driver finally takes a left turn and drives 1 kilometer before stopping. How far and in which direction should the driver drive to reach the school again? Important, pay attention. If he wants to reach the school again, in which direction he should drive? So we have to find the distance and the direction both. Let us find out the distance. I'll take this first value, third value and the fifth value. Remember that always you leave one, so ignore this and ignore this. Now we'll see, this is left and left, so whenever it is left and left we will subtract. So subtract 8 and 2. Always remember, subtract this value from this value. So this will be 8. Since this is left and left, it will be a negative sign. This will be 8 minus 2. Don't do 2 minus 8. It will be 8 minus 2. So 8 minus 2 is plus 6. So here we get plus 6. But since there is one more distance here, we take this value also. And this is left and left. So again we will subtract left and left. So this will be 1. This will be 1 minus 6, which is minus 5. So the value of x is minus 5. Now let us find out the value of y. For y, we will take this 5 and we will take this 5. Since the two directions are L and L, we will subtract them. This is 5 minus 5, which is 0. So value of y is 0. Distance d is given by x squared plus y squared under root, which will be minus 5 square plus 0 square, which will be 5. So the distance d is 5 kilometers. Now let us find out where is he with respect to its original position? The original position of x is north. And the original position of y is north plus left. North plus left is west, but here the value of y is 0, so it will vanish. And in this case, the value of x, pay attention, the value of x first came to be positive 6. It is plus 6. Originally x was in north. The first value of x is positive, so the north here will become south. Pay attention. Whenever the value of x is positive, the direction will be opposite. So originally the north will become south, but later the value of x is negative, which is minus 5. So this south will remain south, since the next step the value is negative. So here x is actually south. Now, with respect to its original position, this person is on the south. If this is the original position, this person is now towards the south, and the question is, pay attention, in which direction should the driver drive to reach the school again? So right now he is in south with respect to the original position or the school. So to reach back the school, he should drive in the north position. I hope you understand the question. To go back to the school again, he has to drive towards north, because right now he is in south as compared to the direction of the school. Answer is option E. In the previous question, here the value of x is positive, so this original, sorry for the mistake, the first value of x is positive, so this south will become north here, and later it is negative, so north will remain north here. So the question is, how far and in which direction he is from the starting point? Answer is 20 meters north. Sorry for the error. 20 meters north. Answer is option C. Next problem. Ram walks 10 meters south from his house. Turns left, walks 25 meters. Again turns left, walks 40 meters. Turns right, walks 5 meters to reach his school. In which direction is the school from his house? So basically they are asking only the direction with respect to the starting point. So original direction of x is south, and original direction of y is south plus the first turn, which is the left. South plus left. South plus left is east. Now let us find out the value of x and y. For x, we will take these first and the third values, 10 and 40. The two directions in the between are L and L, so we will subtract them. This will be 40 minus 10, which is plus 30. So x is plus 30 and y is, we'll take the second and the fourth value. This is R, this is L, we'll add them. This is 5 plus 25, this is also plus 30. Now since the value of x is plus 30, this south will be changed to opposite. It will become north. And this y is also positive, so this east will become west. So his school is in the northwest. Answer is none. I will be sharing the sheet of direction in half an hour. That's all. These are all the questions of directions. You will be able to solve all the problems in the exam based on this. But please revise these topics again. Thank you. We will meet in right now it is 12. We'll meet again at 12:30 and we will start linear arrangement, important topic. Thank you.